Another question about the kinematics. A bus leaves a bus stop at time 0 and travel along the horizontal road until it reaches a second bus stop. Figure 7.1 is the distance time graph for the bus between time 0 and 60 seconds. The question is, the road on which the bus is traveling is a straight, except for a short curved section. The bus travels around this circular curve between t21 and 24 seconds. So this is 21 and this is 24. So this part of the journey is the curved track, mean the circular path. Describe how the motion of the bus between 0 and 10 differs from its motion between 35 and 40. This is distance time graph, and the gradient of this time graph, this distance time graph, is the speed. So look, from 0 to 10, the gradient is increasing, the speed is increasing. And from 35 to 40, 35 to 40, from this point to this point, the gradient of the line is decreasing. So the speed is decreasing. So we will write here first, the gradient of graph is speed. From 0 second to 10 second, gradient is increasing, hence speed of bus is increasing. And then from 35 second to 40 second, the gradient of graph is decreasing. Thus, the speed of the bus is decreasing. So from 0 to 10, speed is increasing. From 35 to 40, this is decreasing. And then we have to look at the size of the gradient. Look at the size of the gradient. In 5 seconds, the speed is changing from this level to this level. How many boxes? 1, 2, 3. But same here, in 5 seconds, just 1.5 boxes. It means this speed, this increase, magnitude, this increase of the speed, the magnitude of the acceleration is small. This is positive acceleration, because in 5 seconds, there is a small increase in the speed. But in these 5 seconds, there is a large decrease in the gradient, decrease in the speed, the deceleration is greater than this acceleration. This deceleration is large, and here the acceleration is small, because here the speed is increasing. In 5 seconds, only 1.5 box. And here, while it's decreasing, in the same interval of time, 5 seconds, 1, 2, 3 boxes change in velocity, decrease in the velocity, decrease in the gradient. So the retardation, deceleration is large as compared to the acceleration. So this is the answer for the first part. You have to mention the acceleration is smaller and the deceleration is larger. So we have to compare these two for this line. The next is the maximum speed of the bus during these 60. So speed of the bus determined by the gradient. Now the maximum gradient, the steepest line, you can take any value between these 2 points because this is a straight line and the steepest line. So take any 2 points. Suppose the first point is this, and this is 30 at the x-axis, 300 at the y-axis. And then we can take this point. This is 20 at the x-axis, and this is 1, 2, 3, 4. This is 180. So the gradient y2 minus y1 over x2 minus x1, 300 minus 180 divided by 30 minus 20. So this is 120 divided by 10. So answer is 12 meter per second. This is the maximum speed, and you have to attempt the whole calculation here. So the answer is 12 meter per second. Next is the average speed of the bus between leaving the bus stop and arriving at the map. So the average speed is equal to total distance divided by total time. Now the total distance represented by this graph is this. And this is 390. So total distance is 390 and the total time taken is 60. So 39 divided by 6, 3 ones are, 3 threes are, 3 twos are. So it is approximately 6.5 meter per second. Okay, correction in part, not the 60-second. We will take, look, before this time it stops. So this time is 39. So 39 and 40. So in between these two, it stops because after this, it comes to rest. The total time taken for this journey is not 60-second. It is 39.5. So here the correction, this is not 60. So it is 39 either or 39.5, and then calculate the answer. Okay, after calculation, this 390 divided by 39.5, you can take 39 also. So it's coming 9.87. So the answer is 9.9 meter per second. This is the average speed for the whole journey while it was moving. Next state, how the velocity differs from the speed. Velocity has direction, has fixed direction. And speed, no direction. Next is there are 3 periods during the 60-second when there is a non-zero resultant force acting on the bus. Complete a statement to indicate these 3 times period and state the direction of the resultant force in that period. So from the graph, 0 to 10, there is acceleration. This is non-zero force because the acceleration is produced. So we will write from 0 to 10 second, there is acceleration. So the resultant force is the forward force because there is acceleration. And the next, it is mentioned that between these 2 times from 21 to 24, circular curve. So there's a centripetal force, and the centripetal force is also a non-zero force. So from 21 to 24, Due to the centripetal force, the non-zero force is acting towards the center of corner. When the bus is turning, so the force is acting toward the center of the curvature. And the next, from this point to this point, the velocity is decreasing. And this point is from 35 to 39 or 40, from 35 to 40. Speed is decreasing. So there's a retardation. So this retarding force is acting backward. So the lorry is going in this direction, it's slowing down, but the retarding force is acting in this direction and the speed is decreasing. It's going ahead, but due to the retarding force, it's slowing down and the force is opposing the motion. So the backward. Next, during the journey, the air resistance acting on the bus varies. State why the air resistance changing during the journey. Air resistance depends on the speed. When speed changes, definitely the air resistance changes. Next, figure 7.1. On figure 7, mark and label with an M a time when the air resistance is at maximum value. I mean the maximum speed, so the maximum resistance. So look at the graph. From this point to this point, the speed is maximum. So this is the M point where the speed maximum and the air resistance maximum, and it remains constant till 35, and then air resistance decreases because the speed decreases. Okay. Okay, another question. Question is, figure 1.1 is the distance time graph of the skydiver who jumps from the balloon at time t0 second. So look at the graph. The first part of the graph shows the motion of the skydiver from when he jumps until he reaches the terminal velocity. Determine the motion of the skydiver between 0 to 20 seconds. Look. From 0 to 20, the speed increases, the gradient increases, and then it becomes constant. So we have to write, first, initial speed is 0. He accelerates its speed, or his speed, increases because the gradient is increasing. And then finally, speed becomes constant because the gradient becomes constant. Look at the graph at 20 seconds. So this is straight line. So mean the gradient constant. Here the gradient is increasing, speed is increasing. And then finally it becomes constant. Speed becomes constant because the gradient constant. Explain the motion of the skydiver between 0 and 20 in terms of the forces acting. So initially, weight is acting. Mean at time 0, the weight is acting. So the acceleration is exactly equal to g, 10 meters per second. As speed increases, air resistance increases. Now the weight is acting down and the air resistance acting up. So thus the resultant force decreases. Hence acceleration decreases. So we have to mention three forces. One is the weight, other is the air resistance, and the third, which is responsible for the acceleration, resultant force decreases. So weight remains same, air resistance increases with speed, resultant force decreases, and acceleration decreasing. So 3 marks for it. The next is using figure 1.1, determine the terminal velocity of the skydiver, indicate any values used for your calculation. So the terminal velocity is the constant velocity. We can take any value, for example, this point, this point. Here, the time is 25 and the distance covered is 1000 meters. Now, the another point, suppose this 50, this one, so it's 50 and its value this one. So 1, 2, 3, 4, and 5. This is 2100. This is 2200. So this is 2200 meter distance. So we have to mention these 2 points. So the first point is 25 and 1000. And the second point is 50 and 2200. Now we have to calculate the gradient. So the gradient for the velocity is y2 minus y1 or x2 minus x1. So 2200 minus 1000 divided by 50 minus 25. So the answer is 1200. 2200 minus 1000, 1200 divided by 25. So we have to calculate this. So the answer is coming 48. So the gradient of this graph is speed, so meter per second. But do remember, you have to show this whole calculation over here. So this is 48 meter per second. Few questions about kinematics, O-level, Igcse. A question is, a car approaches a set of the traffic light. The light changes to red at time 0. Figure shows 2.1. How the speed of the car changes with time. So look at the graph. Initial speed is 20, which remains same for this time, and this time is 1.4 second. And then from 1.4 second to this time, 4 second, there is uniform retardation, uniform deceleration. And then from 4 to the 7, there is another constant deceleration. And finally, it comes to rest at 7. Now, the question is, the car starts to slow down a short time after the light changes to red. Determine the time between the lights changing to red and the car starting to slows down. So it goes red at this time and the brakes are applied at this time. So this gap is showing 1.4 seconds. So answer is 1.4 seconds. Now the question is, state what is meant by uniform acceleration. Uniform acceleration mean the change of velocity is constant in each interval of time mean in every second is constant, mean the delta V is constant. So in each second, the velocity is changing constantly, uniformly, steadily, hence the acceleration is uniform. Next, state how. Figure 2.1 shows that deceleration of the car at 2 seconds and 7 seconds is non-uniform. 2 seconds and the 7 second. Look, at 2 seconds, this is the line. At the 7 second, this is the line. The gradient of the both line is the acceleration. Look, the slope, the gradient of this line number 1 is different from the line 2. So we will write here the gradients of lines are not same, are not equal. Thus, deceleration is not uniform. Next, determine the distance the car travels from the moment of the car starts to slow down until it stops. So this is the time at which it starts slowing down. So we have to calculate the area from this 1.4 to the 7. So we can divide it into two figures. This is trapezium, this is triangle. So this trapezium area is equal to 1/2 base or sum of the parallel side into the height. This is the area of the trapezium. And the second, the area of the triangle, 1/2 base into height. Now for the trapezium area, 1/2, sum of the parallel side. So look, this side is 20 and this parallel side is 8. So 20 plus 8. And the height, the vertical height between these two is 1.4 to 4. So this is 2.6. So it will be 28 times 2.6 divided by 2. So 14 times 2.6. And we will calculate it later. And then the area of the triangle, 1/2. The base from 4 to 7 is 3. And the vertical height is 8. 2 ones are 2 fours are. So this area is coming 12. Now come to this one. Okay, after calculation, this 14 multiplied by 2.6, the answer is coming 36.4 meter. And the area of the triangle is this. So this distance covered is 12 meter. This is 36 meter. When both are added, the answer is coming 48.4. And it can be written as close to this answer, 48. So this is 48.4 meter, or you can write 48 meter. So this is one of the questions.